Okay, so I know I talked about this in period 6, but period 5, I forgot to tell you about this. And I figured out what the problem was with your calculator. It wasn't the hamsters at all, it was us. So when I do the one var step, one var stats on this, or any other probability distribution, the x bar should in fact be the mean or expected value. And at the same time, the sigma x should also give me that value. They should match. And the reason they didn't on this is because we forgot one teensy little tiny thing, which is actually really a big thing. If I said, oh, by the way, we were going to figure out what your grade is, and you knew that this was your test average, so this was tests, and this was homework, and your homework average was an 87, and your quiz average was, let's say, a 90, and that these are weighted, so the probability for each of these is as follows. If I stopped there, would you be able to get that last value? And hopefully you said yes, because you know that all of these must total 1 in order to be a legitimate probability distribution. And so here's the deal. When you look at this big cat cache, is it a legitimate probability distribution? And the answer is no, because these do not total 1. So I would ask, what's missing? And first, in terms of, well, what else could I win? Oh yeah, nothing. And what's the probability of that happening? Well, it's 1 minus the sum of the current p of x's. And so a quick way to do that is, since you have this in list 2, is to go figure out on your main screen what's 1 minus sum of list 2. Remember, this is in list math number 5. And it'll tell you, this ended up being something like 0.778826, I think. And so now when I add that to the list, and I do one var stats, these two values are now equal. And I believe that the expected value turns out to be 67 cents. So now you can in fact always look at x bar when you're trying to find the mean, even if it's a weighted mean, as are all probability distributions. Okay, so moving on to the next page. Okay, so this was the set that we were looking at in class today, and I want you to double check and make sure that you have all those numbers correct in your notes. And then after you have double checked set A, which we pretty much got finished in class, we want to look at creating this new set B. Only this time I'm supposed to take every value in x and subtract y. So I know 6th period we got it done, 5th period we didn't get this finished, so you're going to need to follow along and make sure you have this. So if I take the 1 out of set x and I subtract first 15, I'd get negative 14. And then if I subtract the 16, I'd get negative 15. And then if I subtract the 17, I get negative 16. And then next, I'm going to take the 4, I'm going to repeat. I'm going to subtract the 15, which would be negative 11, and subtract the 16, which is negative 12, and subtract the 17, which is negative 13. And then I'm going to repeat that process, but this time I'm going to use the 7. So 7 minus 15 is negative 8. 7 minus 16 is negative 9. And 7 minus 17 is negative 10. And so I want you to now find me the mean for set B by putting those values into your calculator and doing one of our stats. So pause the video long enough to do that. And hopefully you came up with those numbers. So now I'm interested in how it is that I might be able to arrive at this value, the mean of them added together, if I compare the mean of x and the mean of y individually. And hopefully what you said is, well, if you add them together, you of course get this one over here. And so what that leads me to believe is the mean of the sum is equal to the sum of the individual means. So this one here is equal to the other two individually. And furthermore, if I compare the last one to those first two, I might know that, hey, if I subtract 4 minus 16, I'll get negative 12. So again, that leads me to a new rule, which is the mean of the difference is equal to the difference of the two means. Again, making sure that I keep them in the same order. Now, what about standard deviation and what about variance? Do you notice anything there where things maybe perhaps have added or subtracted? And hopefully what you noticed is that this is in fact the sum of these two. And wait, so is this. So that leads me to a new rule for the variances, which it appears that if I look at the variance of the sum, it's equal to the sum of the two separate variances. And likewise over here, the variance of the difference is still equal to the sum of the two individual variances. So it doesn't matter if I'm adding or subtracting on variance, the two random variables, the variances still add. So now my curiosity is, what about standard deviation? Well, my question is, how do I get standard deviation if I know the variance? And hopefully you said, oh, I know that, Torres. You just square root it. So this, of course, would give me standard deviation of x plus y. But whatever I do to the left, I must do to the right. And I cannot split those. They must stay together. And so what I want you to do is check with your calculator, is this 2.58 the square root of the variance? And so same thing here, if I'm looking for the standard deviation of the difference, I would square root the left. And of course, whatever I do to the left, I must do to the right. So it's still the square root of the sum. So this is the last page of your Chapter 7 notes. And now that we've discovered most of these, it'll be fairly easy to fill them in. So I know that if I multiply and add to my random variable, that it adds and multiplies those same values to the mean. And we saw that on page 1 of the other worksheet. And we actually wrote the rule for that down on problem 7. And if I take two random variables and I want to know the mean, well, it's the same as adding their two separate means, which is what we were just doing on page 2 when we looked at mu of A in that table. And at the same time, in that table, we looked at mu of B. So this one was mu of B, and this one was mu of A from page 2. And we said if we subtract them, that it's the same as taking the two answers you had to start with and subtracting them individually. And then for variance, well, adding doesn't affect anything, so I don't need to worry about what's going on here. But multiplying does. As a matter of fact, it's probably easier to start with the standard deviation first. So again, adding doesn't affect anything, but multiplying, of course, does. So we said we get this, and then when I square that to get back to variance, I'll get b squared times the standard deviation squared, or times the variance. And if I'm adding independent random variables, and this is important, that if they're independent, then I can simply add their variances. And that's what we're doing again on page 2. And same thing, if they're independent and I'm subtracting, the subtraction still adds.